All right, so in this video, I'm with you guys on page 19, and we are taking a look at some word problems. And the goal of this video is to basically read a scenario and write an equation. So we're essentially translating all of these words in English into an algebraic equation. Now up top, I've got just a list of some key words here. You might want to go ahead and jot them down. If you see the word per or each, that means like multiplying. So if it's like $3 per something or $3 for each of something, you would show that with like a 3 times whatever it is, so like 3 per whatever. Now we're going to see some problems that have the words monthly fee. If you pay something every month no matter what, that's just a constant. That's going to be like a plus 10 or a plus 15 plus a certain amount. A down payment, we're going to see that in a word problem later, and a flat fee. These are all things that you'll be seeing for constant keywords, okay? So remember, coefficient is a number with a variable, and a constant is a number that you would add or subtract all by itself at the end of the expression. All right, so let's dive on in here with our very first scenario. We have that a fitness center charges $2 per visit. That might be like $2 each class you take. And then there's a $10 monthly fee no matter what. So the classes, that could be like something like a yoga class or a Zumba class or kickboxing. So you might get charged for a class that you want to go to for special classes, but to use all the other equipment like the treadmills or to lift weights and things like that, it'd be $10 a month no matter what. Now, last month, Nolan's gym bill payment was $34. So last month, he paid the gym $34. We want to figure out how many times did he go work out at the gym last month. So the first thing we're going to do is generate an equation to go along with this. And we've got that it's $2 for each visit, so $2 per class you take. And then it's going to be a $10 monthly fee no matter what. And Nolan spent a total of $34. So if we drop the line and solve it, we're like, okay, we know that he had to spend $10 just for the monthly fee. So that means it was $2 per visit, and that was $24 towards his total bill. So now we're going to divide both sides by the 2. And that cancels out, and 24 divided by 2 would be 12. So we can see that he visited the gym 12 times or took 12 classes, okay? 12 classes. So again, the goal of this video is to read these scenarios and write this equation. And hopefully, once the equation is written, you'll already know what to do to solve, okay? Now to check, we can also check real quick. We know that $2 for 12 classes would be 24 bucks. And then it's the $10 monthly fee no matter what. So when you do the 24 plus 10, we can verify that that would in fact be the $34 that Nolan spent. Okay? All right, let's go ahead and take a look at the next problem. All right, so we have that each year, the 7th grade goes on a field trip to the Marine Corps Museum. Last year, students were split into 8 bus groups, and each of those bus groups had 2 parent chaperones. So my first question for you guys is, how many parent chaperones are there? If there's 8 groups, each has 2 chaperones, that's going to be 16 adult chaperones that we have, okay? 16 adult chaperones. Now we also know that 400 total people took the buses to the museum. So we want to figure out how many 7th graders were on the bus. So if we have 8 bus groups plus our 16 parent chaperones, that's going to equal the 400 total people who went. So now let's drop our line and solve. And we're going to get rid of the 16 parent chaperones. And that cancels out over here. So we have 8 bus groups. And that's going to be 384 7th graders total. So if we now divide into those 8 groups, when you take 384 and divide it by 8, when we solve, we're going to get 48 kids in each group. There's 48 kids in each bus group, so 48 kids on each bus. Now, if you have those 48 kids times the 8 groups plus the 16 people, or 16 chaperones, you would be at 400 total people. All right. Now, this next one has a table of values, and I've got a lot of it filled out here for you. So we're just going to read the problem together, and then I'll explain the table of values. So Sam's family is going camping. Now the campsite charges $30 just to rent the space, and then $20 for each night that you're going to stay. So when camping here, it looks like you might have an RV that you could use, and you could just park your RV, and you're going to have $30 to rent the space. or it might be a campground where you have a tent. Either way, it's $30 just to rent the space, and it's going to be $20 for each night that you stay camping. So we want to write an equation to represent the cost of staying at the campsite for a certain number of unknown nights. So the cost here would be the $30 just to rent the space plus the $20 per night. Now this is just a math grammar thing, kind of like where you put a period at the end of the sentence. When we format our answers, y'all, the constant always comes last. So it's $20 a night plus the $30 no matter what just to rent the space, okay? So the constant is always last. That's why you see the table of values using the $20 per night that you stay, and then you're going to add the $30 just to rent the space. So what this table of values does is it allows us to explore multiple different costs depending on the nights that you stay. So if you were to only stay one night, well, that would be 20 bucks plus the 30 to rent the space, and that would cost you $50 total. Now, if you stay for 2 nights, that's going to cost you 40 bucks, but then plus the 30 to rent the space would be 70. If you stayed for 3 nights, that'd be 60 bucks plus the 30 to rent the space. If you stayed for 4 nights, that'd be $80 plus 30 is 110. And if you stayed for 5 nights, that's going to be 100 bucks, and 100 plus 30 would be $130, okay? Now in the next part of the video, we're just going to kind of review here independent versus dependent variables. Independent is what you have control over, and independents are always represented right here. These inputs are all values that represent the thing that you have control over. So the variable that represents the thing that we have control over would be the variable n. It represents the number of nights, okay? Now the cost simply depends on the number of nights you stay. So the dependent variable here would be C for cost. Now again, Sam's family has control over the number of nights that they stay, and what you can control or change, like if you want to stay 2 nights versus 3 nights, that's considered independent. And of course, it's easy to see that the cost would depend on that. Now for the next question, it asks, how much is Sam's family going to be charged if they camp for 5 days? We've already figured that part out right here in the table of values, and so here's the work for it. It was $20 for 5 nights, and then plus the $30 no matter what would be $130, okay? I want to remind you guys that this part right here, this we simplified because we had all of our parts, but we could solve, if you saw an equation, it might change the scenario to say, if Sam's family spent $130, how many nights did they stay? And so you can say, okay, so if it's $130 that he spent, and it's $20 per night, and it's a $30 fee just to rent the space no matter what, you guys know how to solve, and you would subtract your 30, and you'd subtract the 30, and you get 100 bucks over here, and then you have 20 in. So then you would divide by this 20, and you would divide by this 20. So here's would be the 5 nights that Sam's family stayed if you were given the total amount. So that's the other thing that you guys now know how to do. You guys know how to solve the equations, and it really just depends on what it's asking you if you're simplifying or solving. Now let's flip over. And what you guys are going to do is you're going to try this problem all by yourself. You're going to pause the video, just pause it, and then try it. And when you hit play, we'll have some stuff filled in to see if you're on the right track. All right, so let's see how you did with this. So the equation here would be that the cost is $1.50 per mile, and then it's $2 as a flat fee. Oftentimes when you get into a cab, there's already money on the meter, and then it's going to charge you for the time and distance. So here it's $1.50 for each mile that's driven, and then there was already $2 on the meter, okay? Now, you do not necessarily need to write the 0 for the $1.50. You could put 1.5, and you don't need to put the 0.00. You don't need to put that because you could just put 2 for $2. So that's the equation here. It's $1.50 per mile plus a $2 flat fee no matter what. So what you were to fill in here was if you went 0 miles, how much would it cost? Well, that would still be just the $2 flat fee. Again, if the taxi hasn't moved yet, there's already $2 on the meter. Now, if you go 5 miles times $1.50, that's 7.5, and then plus the $2 no matter what, that would be $9.50. And notice here, because we're talking about the total cost, I am making it look like money. So if you filled this in appropriately, then over here, what you would have gotten would have been a $9.50, then a $17. Then over here, we'd have a $24.50. And followed by a $32. Okay? Now, what would you have control over here? I mean, you're the one in control of how many miles the taxi is going to have to travel, because you're the one telling it where to go. So you are in control of the number of miles. So M is the independent variable, and C, the cost depends on it. So notice that here, the costs, that's dependent, and it depends on the number that we had plugged in here for M. Now, how much would a customer be charged if their cab was 18 miles? So if you do the 18 times the $1.50, it's okay if you need a calculator for that. I'll bust out my calculator. So we've got the $1.5, $1.50 for 18 miles. And then we're going to simply add the $2 to that. So that would cost $29. The answer for that one would have been 29. Okay. All right, so that takes care of that problem. And now here we are taking a look at Emily's grandfather. So Emily's grandfather is 73. So 73 is, there's my 73 is. And now we have that he is 5 years more than 4 times Martha. So here's a then. So we've got 4 times Martha first. Now show me 5 more than that. So when we drop our line and solve here, folks, we're going to subtract 5 on both sides to cancel that out. And we get 68 equals 4M. Now we divide both sides by the 4, and we get that Martha would be 17. So again, the point of this video is to review that we're taking these real-life word problems and translating them into these algebraic equations. All right, now we're going to take a look at number 4. So in number 4, we have that Rick bought a computer for $1,900, and he made a down payment of $400. Now I want to remind you guys that on the first page here, I had constant keywords, and down payment is a constant when you have it in an expression. And so what that means with a down payment, that means you already paid $400 right there in the store, and then you're going to be paying the rest in equal payments monthly after that. So if P represents the amount of each payment, how much would each payment be? So again, if it's $1,900 for the total computer and you pay $400 already in the store, all you have left to pay would be $1,500. And if those get paid, that $1,500 gets paid in 5 equal payments, we would divide that by the 5 to figure out how much each payment was. So to write an equation here, what we have is it's $1,900 for the computer, and you're going to pay for it by the $400 right then and there in the store. That's the down payment. And then you have 5 payments after that. Now we're going to switch the order here because the constant always comes last. Again, that's just like a grammar rule. So when you're looking for your answer over here, it's going to be answer choice D. You're going to have the 5 equal payments plus the $400 no matter what, and that shows the constant coming last. All right, and now here we are on this last problem here. We're on page 20, the last problem. And we have that Ian and his friends are going to go bowling over winter break. Now the bowling alley charges $3 just to rent your bowling shoes, and then it's $5.50 per hour that you're bowling. So we want to write an equation here to show the total cost based on how many hours you've been bowling. So the cost is going to be generated. It's going to be the $5.50 per game, no matter what. And then you have the $3 just to rent the shoes. Now in this situation, you have control over the number of games that, or excuse me, not games, I have a G there. It should be the number of hours, my fault. It should be the number of hours, excuse me. So $5.50 per hour of bowling plus the $3. So what you have control over is the number of hours how long you're going to be bowling. So the variable that represents that here was h for hours. And in this situation, the cost depends on that, and c is the variable that represents cost. Now, if Ian's family is going to be, or if Ian's going bowling, I should say, for 3 hours, the 3 hours times 550 would be $16.50, but then to rent the shoes would be an additional $3. So for this answer here, we're going to get $19.50, okay? Now I want to ask you guys right here for part C, are we simplifying or solving? Did we simplify or solve in part C? And in part C, all we did was took our expression and found the total. So in part C, we simplified. Okay? Now, we took care of page 19 and 20 in this video, and so now what you're going to do is you're going to attempt page 21 here on your own, and there's no video for that, but that's what you're going to be working on next. Thank you.